All right, so this is a continuation of your Open Notes quiz review. Let's start with question number 7. So it says, question number 7 says, to balance a chemical equation, you can change the coefficients. The coefficient is just the number in front of your molecule or compound in a chemical reaction. It's just something you need to memorize. So that's number 7. Number 8, when the reaction below is balanced, what coefficient applies to H2? Your answer should be B3. When you just look at this chemical reaction without balancing it, a lot of you chose D1, which would be correct if this was already balanced, but it's not. If you don't know how to balance equations, you probably want to revisit the lesson 5 video, Balancing Equations, on Edpuzzle. All right. Questions 9 and 10 was crossed off of your quiz, but if you want to see what these questions actually are, they're based off of mostly lesson 6 and part of lesson 5. These are the answers. You can use them as extra practice problems. So question number 1 in short answer I actually threw out, so you guys actually got just 2 extra credit points on your quiz, unless it put you over, which then I just rounded up to like 15 out of 15. Anyways, so here it says, consider the following reaction between sodium cyanide and a solution of hydrochloric acid. So I'm looking at this reaction, and then it says, describe in detail what you would observe if you carried out this reaction. So if I carried out this reaction, the only thing I'm really looking at is the product side. Anything where it says you did the reaction and you're recording the observations, something like that, you're just looking at the products. So here I have NaCl, which is sodium chloride or salts, aqueous, which means it's in water. So you have something, even if you don't know what NaCl is, you have something dissolved in water. So you have a solution of water and HCN gas, so something gas. So you have a solution of water with gas bubbles of HCN. That's pretty much all I would be looking for. All right, so question number 2 says, examine this chemical equation. And then does the equation describe a chemical change or a physical change? I kind of gave away the answer when I was reading that, but it basically says it is a chemical change, because even though, if you look here, CHNO plus plus CHO produces CHNO and CHO, all of the elements are arranged in the same way. The key thing is that the subscript is different for each one. So if I drew out all of these molecules, they would all look different because my subscripts are different, right? So if my subscripts are different, or if my elements have rearranged in a certain way, that automatically means it's a chemical change. So chemical change because the atoms have rearranged. Number 3 is also from lesson 6. So it wasn't part of your quiz. You didn't see this question. I crossed it off. But if you want to use this as a practice problem, essentially it's a combination reaction, because you start with 2 reactants, and those 2 reactants combine to form one product. So anytime you have multiple reactants and then you end up with just one thing, one product, one molecule, one compound, whatever you want to call it, that's a combination reaction because it combines. Question number 4, the following reaction takes place in a beaker, blah, 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 blah. If the mass of the beaker and its contents are measured, how will the final mass compare to the initial mass? I was surprised by how many of you got this wrong. But essentially, you should know that the mass should be the same, and this is because of the law of conservation of mass. Cannot write tonight. Conservation of mass. Right? So anything that it weighs before, it's the same weight after. We did a whole lap on it. So balancing the following equations. So imagine I didn't write the answers already. I'm just going to go over this process once. So I'm going to draw an imaginary dotted line that goes down here. So this side is my reactants. This side is my product. I'm going to list out all the elements I have. I have Fe and I have oxygen. Right, on this side, I also have Fe, which is iron, O, which is oxygen. So here, if I ignored all these numbers, I'm just going to go ahead and erase them because that would be helpful. All right, Fe by itself, this time in my reactants, I only have one of them. Oxygen, my subscript down here says 2, so therefore I have 2 oxygens. Right here in my product side, Fe, I have 2 of them because my subscript is 2, so Fe is 2. Oxygen, my subscript is 3, so I have 3 oxygens. Therefore, it's unbalanced. So sad. I have to make them happy and balanced, meaning that whatever number is next to Fe on this side needs to be the same on this side, right? So let's do that. So in chemistry, there's not a lot of subtraction. You can only add things in life, and you can only add to the coefficient, which is this blank spot up front, right? So Fe, there's 2 on this side, so I want to add 1 more on this side. And I can do that by changing it to the coefficient 2, because 2 times the non-existent 1 over here, because if there's no number, that means I have 1 of that element. 2 times 1 will give me a total of 2 Fe, or 2 iron elements on my reactant side. Cool. So now my iron is balanced, oxygen, not so much. So what I need to do next is to figure out how to balance my oxygens. Well, I can add another 2 here, right? I'm just trying things out, right? 2 times 2 will give me 4 oxygens total, and that's not so great because I have 3 oxygens here. But what I can do is multiply this by 2 again. Right, so that gives me 4 irons and a total of 6 oxygens, right? Because 2 times 2 is 4, 2 times 3 is 6. Now everything's out of whack, but that's okay. Because if I go back on this side, I'm just going to keep adding. There are a lot more functional ways to do this. You just have to try it. Or some of you guys can probably do this mentally in your head. Either way, it's fine. So Fe 2, I'm going to change this to 4. That gives me 4 irons. For oxygen, I need to get 6. I know that if I just multiply 2 times 3, I can get 6. Right? So now it's 4, 3, and 2 should have been your final answer.